Good day, students. Welcome to part 10 of Proof by Mathematical Induction. Remember that a wide collection of clips can be found on mathgotserved.com. Before we get started, let's review the plan of attack. Let's go over the plans that we're going to use to guide our problem solving process, okay? All right, so let's write this down, the plan. Now, our plan can be broken down into three parts. Part number one is the base case. The base case is the smallest value in the set of natural numbers that can satisfy the statement. Okay, so in this problem, we deal with the set of natural numbers. So in this case, for the base case, we're going to have to show that n equals 1 is true. All right, that's the foundation or the base case. Step 2 is the inductive hypothesis. All right, inductive hypothesis. We're going to make an assumption here. We're going to assume that n equals k is true for some n in the set of natural numbers. And then the third part, the longest and sometimes most complicated part of the proof is the inductive step. Okay, inductive step. So for the inductive step, we have to show that n equals k is true, follows that, or implies that n equals the next step, k plus 1, is also true. All right, so if we can accomplish all of this, then we'll be done with our proof. All right, let's go ahead and take a look at the proof. So for question number 10, we want to prove that 1 plus 5 plus 9 plus 13 plus plus 4n minus 3 is equal to 1 over 2n times 4n minus 2 for all n in the set of natural numbers. Okay, so that's what we're going to prove. So to get started, let's start with part 1, which is the base case. So what are we going to show for the base case? For the base case, we have to show that n equals 1 is true. All right, remember the first natural number is 1. That's the smallest one that there is, okay? So to do that, we're going to plug in 1 into both sides of our equation. So we have 4n minus 3 is equal to 1/2 n times 4n minus 2. So if we plug in 1 on the left side, we have 4 times 1 minus 3. Question mark, is it equal to 1/2 times 1 times 4 times 1 minus 2. So is this a true statement or not? Let's work this out. 4 times 1 is 4, minus 3 is 1. Is 1 equal to 1/2 times 4 times 1 is 4, minus 2 is 2, 2 times 1 is 2. Simplify this further, you have is 1 equal to 1, and the answer is yes. So our base case is sound. All right, let's move on to our inductive hypothesis. So for an inductive hypothesis, we're going to be making an assumption. We're going to assume that n equals k is true for some k in the set of natural numbers. All right, so let's assume that that's true. So what does that look like? All we're just going to do here is plug in k for n in the original problem. Okay, so you see this original problem right here. We're going to plug in k for n on both sides of our equation. So that's going to look like this. We're going to make our assumption. Assume, let's change the color there. Assume that the statement 1 plus 5 plus 9 plus 13 plus dot 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 plus, instead of 4n minus 3, we're going to have 4k minus 3 is equal to 1/2 times k times 4k minus 2 for some k in a set of natural numbers. All right? Okay, so there is our inductive hypothesis. Next part is the inductive step. Part 3, the inductive step, the hard part. Inductive step. Now, what are we going to do here for the inductive step? We want to show that if n equals k is true, that follows that n equals the next step, which is k plus 1, is also true. All right? So prove that the next step is true using this assumption as a component of your argument. All right, so let's start by rewriting the left side of this statement or the problem, and then we're going to take the next step. Okay, so if we write the left side, we're going to have 1 plus 5 plus 9 plus 13 plus dot 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 plus 4k minus 3. Now the next step is plus 4. Let's change that. Plus 4, instead of k, we're going to have k plus 1 minus 3. All right? Now we're going to use our inductive hypothesis here to make a substitution. All right, so what's the substitution we're going to make? This piece of our inductive step right here, we can substitute it with another value that we stated was equal to in our inductive hypothesis. We know that this entire expression is equal to 1/2 k times 4k minus 2. All right, so let's make that substitution here. So this is going to be equal to, say it's equal to 1/2 k times 4k minus 2. And then we can simplify this a little bit, plus 4 times k is 4k. 4 times 1 is 4 minus 3 is 1 plus 1 there. And then this is, let's put a side note here, by assumption in part 2. Okay, so we're making use of our assumption in part 2. All right, now, so let's go ahead and simplify this a little bit further. So let's see, what can we do here? Well, in order to make our life easier, it's good to have an idea as to what the target is. Okay, so I'm going to make note of what the target should look like and trying to simplify it into a form that's easy to arrive at. Okay, so what is our destination result going to be? So what it's going to look like is the right part of our inductive step with all the k's replaced with k plus 1. So what is that going to look like? We're going to have 1/2. I want the other view. Okay, so this is our target. Okay, our target is 1/2 times, instead of n, I'll put k plus 1 times 4 times k plus 1 minus 2. So this is what I want this expression to simplify into. Okay, it's good to do this so you can have an idea how to manipulate your expression to get your your intended target. So let me simplify this a little bit more so I can have an easy expression to aim towards. So 1/2 k plus 1 times, distribute the 4, you have 4k plus 4 times 1 is 4 minus 2 is 2, so 4k plus 2. Okay, so now the goal is I want to simplify this expression or manipulate it to get this expression right here. So let's do that. Let's see. There's a 1/2 factored out, so how about we go ahead and factor out the 1/2? There is a 1/2 here. I need a constant that I can extract 1/2 from there. So let's rewrite this as 1/2 k times 4k minus 2 plus 2 over 2 times 4k plus 1. Okay, now it's easy to extract 1/2. So if I extract 1/2, I'll have 1/2 times, now we can distribute this k while we're at it, times 4k squared minus 2k plus, if we factor out the 2 from this denominator right here, we're going to just distribute this 2, right? So let's rewrite it again so you can see 2 times 4k plus 1, okay? Because I factored out 1/2 from these two quantities right here, so I have that. Now I can distribute this 2 to both sides, so we have 1/2 times 4k squared minus 2k plus 2 times 4 is 8, 8k plus 2 times 1 is 2. Simplify this a little bit more, we have 1/2 times 4k squared plus 6k plus 2. Now let's factor this. I'm going to use factoring by grouping. So make a little x right here. The AC method. AC is 8 and B is 6. Two numbers that multiply to give you 8 and add to give you 6, 4 times 2. So we have 1/2 times 4k squared plus 4k plus 2k plus 2. And then we can break it down the center and factor by grouping. So go ahead and do that. So I'm going to have the 1/2 still stays outside. 1/2 times, take out 4k from these two. We have 4k, and then we have, we're left with k here, k plus 1. Take out 2 from these two, plus 2, k plus 1 also. So let's factor out the common factors, k plus 1. So we have 1/2 times k plus 1, and then times what's left on the outside, 4k plus 2. That's excellent, because that's exactly what we have down here. That's our target. So let's go ahead and express this expression in this form. We already know that they're the same, so this is going to be equal to. Let's also indicate what the right side was. So we have 1 plus 5 plus 9 plus 13 plus plus 4k minus 3 plus 4k plus 1 minus 3 is equal to 1/2 times k plus 1 times 4k plus 1 minus 2. That's exactly what we want. All right, so let's go ahead and state the conclusion of our proof. So we just simply state that since the statement is true for n equals 1 and truth for n equals k, implied that n equals k plus 1 is also true. The statement, you can see then the statement, and the statement is true for all natural numbers, okay, for all n in the set of natural numbers. So that's basically that. You place your box to indicate that your proof is complete. But thanks so much for taking the time to come to watch this tutorial, and do feel free to subscribe to our channel for updates to other cool clips such as this. And do post a comment in our comment section to let us know what you think about this presentation. We'll appreciate it. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.